This is lesson 19 on reductio ad absurdum. In the last lesson, you saw that the conditional proof was a powerful method of simplifying arguments whenever there's a conditional somewhere in that proof. Today, you're going to see something similar with the reductio ad absurdum. Reductio ad absurdum means bringing or reducing to absurdity, in Latin, of course. In a reductio, we assume the opposite of what we are trying to prove for the sake of argument. If this assumption leads us to a contradiction, we can conclude what we were trying to prove at first before the reductio. This method might sound crazy to a regular person, but you all are logic students. You remember that the shorter truth table method for validity uses this exact form of proving the opposite. If you're trying to prove something is valid, you assume the argument is invalid with true premises and a false conclusion, of course. And if that assumption leads to a contradiction, we get to conclude that the argument must in fact be valid. And of course, you did the same sort of thing again when you were trying to prove that arguments were logically equivalent by assuming that they weren't logically equivalent. And when that led to a contradiction, you were able to conclude that they were, in fact, after all that work, equivalent. This is also a common form of reasoning in other subjects, such as mathematics, philosophy, and theology. For example, to prove that division by zero is not allowed, we can actually do a reductio. We can assume that division by zero is allowed and show that that leads to an absurdity, and we can do it this way. We know that 0 equals 0 by the reflexive property of equality. We know that anything times 0 is 0, such that 0 times 1 is equal to 0 times 2 by the multiplicative property of 0. Now, here's where we make our assumption. We assume that division by 0 is allowed, and so we're going to divide both sides of our equation by 0. When you divide by 0, the 0 cancels away, and you get 1 equals 2. Those of you who like to count on your fingers, do it now. 2 does not equal 1. This shows that division by 0 leads to absurdity, and that shows our assumption was wrong, and that assumption was that division by 0 is in fact allowed. So that's the method of reductio ad absurdum. You assume the opposite of what you're trying to prove, you show that that leads to an absurdity, a contradiction, and then you conclude what you're trying to prove. It's also another powerful tool for formal proofs, which of course is our purpose today. So let's use this idea to prove the rule of addition without using the rule of addition, of course. Normally that would be impossible. The only rule which adds a new proposition is in fact addition, but I can do that with reductio ad absurdum. I'm going to assume this way: P therefore P or Q. I'm trying to conclude the rule of addition, of course, so I'm going to start by assuming the opposite of what I'm trying to prove. I'm trying to prove P or Q, and so I assume not P or Q. RAA is my justification. So I assume the negation of what I'm trying to prove, justified as reductio ad absurdum assumption, or like I said, RAA. Now I'm going to show that that leads me to a contradiction. Now, not P or Q, you should recognize, is equivalent to not P and not Q by De Morgan's theorem. So that's my next step. Then I can simplify that to not P by simplification. Now notice this. In step 1 I have P, and in step 4 I have not P. Then I get P and not P, steps 1 and 4 by conjunction. Now I assume not P or Q, and I can come to this self-contradiction. Because assuming not P or Q can lead me to a self-contradiction, I then conclude P or Q by 2 through 5 reductio ad absurdum, RA. So I conclude what we are trying to prove, justified as reductio ad absurdum, with the line numbers from the assumption through the self-contradiction. In this case, 2 starts with the assumption, and step 5 ends with the self-contradiction. It's an unusual way of writing a proof, but it's another tool for our budding arsenal. So let's do another couple of proofs. We're going to do each proof twice. Once without reductio ad absurdum, and the other time with reductio ad absurdum. And you need to decide whether you think the reductio ad absurdum method is a better method. Let's say I'm trying to prove if P then Q, if not P then Q, therefore Q. How can I do this? Well, looking at if P then Q and if not P then Q tells me that I'm going to do some sort of hypothetical syllogism because I have 2 conditionals, but I have to get the middle parts to match. Well, my middle part can be that not P there, so I'm going to take step 1 and do a transposition on it. If not Q, then not P. That leaves me with if not Q, then not P. If not P, then Q. Therefore, if not Q, then Q, by the hypothetical syllogism. Now, this if not Q then Q will turn the if then into a not or by material implication. Not Q or Q. Next I can do a double negation, Q or Q, and then we get the unusual rule of tautology to conclude Q by itself. Again, it's not easy to see that you have to do the transposition and the hypothetical syllogism and then turn that step into a Q, especially when you add the fact that we don't normally use tautology that often. But now let's try that same proof with the reductio. First step, we assume the opposite of what we're trying to prove. If P then Q, if not P then Q, therefore Q. So we assume not Q, justified with RAA, the reductio ad absurdum assumption. Modus tollens is the obvious next step. If P then Q, not Q, therefore not P. Then we'll use another modus tollens. If not P, then Q, not Q, therefore not P. Now we have these two contradictory statements. We just need to bring them together with the conjunction, not P and not P. This is clearly a contradiction. The form is something and not something. I'll pause to note that just as with the conditional proof, it's common to use modus ponens, so you'll notice that with reductio ad absurdum, it's common to use the rule of conjunction. Anyways, now that we've deduced that self-contradiction, we can conclude the Q, the opposite of what we assumed. Steps 3 through 6 are A. 3, of course, is the number of the assumption. The 6 is the number of the self-contradiction. So what's your verdict now that you've seen both? Well, I think it's clear that even though it's about the same number of steps, it's much simpler with the assumption. Now, the reductio ad absurdum assumption has some limitations, just like the conditional proof. So remember these things. A reductio may be part of a longer proof. You don't have to end the proof with RA. You can just be trying to prove something in the middle of a longer proof, as long as you keep that reductio ad absurdum as a self-contained little section. The RAA may only be made when using RA. You can't make the reductio ad absurdum assumption, assume the opposite of what you're trying to prove, and then stop in another few steps without using the reductio ad absurdum. That's pretty obvious too. And the third restriction, the reductio ad absurdum is self-contained. You may not select one step out of the middle of RA to use later in the proof. So here's our summary. In reductio ad absurdum, we assume the negation of a proposition, justified as RAA. If that negation leads us to a contradiction of the form P and not P, then we may conclude the original proposition justified as RA. Okay, let's take a look at exercise 19. Again, most of these proofs you could also write without using a reductio, but do them all with the reductio for this lesson. So with these, we're going to start, always, by assuming the opposite of the conclusion by RAA. In problem 1, we'll start with not P and try to reach some self-contradiction by line 7. In problem 2, assume not P and try to get some self-contradiction by line 7 again. In 3, we're going to start by assuming the not Q and reach the contradiction by line 6. Notice when we assume the opposite of the conclusion in 4, not if Q then Q, the conclusion itself is already a self-contradiction. Steps number 3 and 4 are taken up in just getting it to the form P and not P, and in that one you won't use line number 1 at all, which is kind of fun. On to the assignment. On the wall behind me, you can see the 50 adorable fallacies from the amazing Dr. Ransom's Bestiary of Adorable Fallacies. This is the informal fallacy book that all of your family is going to love reading together. Second book I wanted to show you is a book written just for classical homeschoolers, Classical Me, Classical Thee, Squander Not Thine Education. This book explains why you have to do all the classes you're trying to do. So please remember to subscribe and hit the bell. You can check the links below in the description for these 2 books and anything else from Logos Press. Thanks for watching.